This conference will now be recorded.
Hello everyone, this is Manohar Topsani, and we are going to start with scalar programming. And let's start with discussing what is scalar and why do we need scalar. What are the important pros and cons about scalar? So let's start discussing about all that stuff in today's session. So I hope everybody is clear with this, right? Am I audible to all of you guys? Thank you very much. Okay, just you can chat in the chat box if you have any queries. Otherwise, you can ask me in the once the topic is done. So you can interact in what are the way best possible for you. So now today we are going to start with this. So the first thing we are going to discuss today is,
This conference will now be recorded.
so here today we are going to talk about this one. What is scalar? Okay. So let's see this now. When you talk about scalar, so we have to understand all this. What is scalar, and then all this is about scalar. Actually, whatever we have highlighted here, the list of topics we see this clearly explains about what exactly scalar is. So scalar is object oriented, it's functional, as well as it is statically typed. Also, it is extensible, and scalar also interoperates. And this is what we are going to talk in the next couple of minutes. So let's understand all this in this session today. And after this, once we get an idea, then we'll discuss about the software installation and software requirements and installation and running the basic programs. We see all that stuff. Then we start with the language fundamentals of Scala. I hope this is clear for all of you, right? So now let's start with this. So when you talk about Scala is object oriented. It is functional, it is statically typed, it is extensible, and it is interoperates. What are all this? Let's understand. Let's have an eagle eye on all these things. Are you ready for that? So when you talk about the first one, so object oriented. Scala is object oriented. So now the question is, what is an object oriented? Okay, let me explain this. What is object oriented? When you talk about object oriented, it means let me increase a font a bit. Any object oriented programming has should have certain features like object, like class, like encapsulation, abstraction, inheritance, polymorphism. All these are OOP features. If any language has these features, we call it as object oriented programming. Is this clear for all of you, gentlemen? Any language has these features. What do you call this as? We call it as an object oriented programming language. So Scala has all this. So Scala is an object oriented programming. And one more thing is when you talk about Scala, it is pure object oriented programming. What is Scala here? Scala is a pure object oriented programming. I'll just simplify this with the word OOP. OOP means object oriented programming. So maybe you can ask me a question, sir. We have heard about a couple of other object-oriented programming languages like Java, like Python, like C++, like C Sharp. Can you do you mean that these are all not pure object-oriented? I don't say that, but we can say a bit less object-oriented. They are less object oriented. So when you talk about Java is less object oriented comparative to Scala, because in Scala everything is an object, including data types. But in Java, still data types are primitives. You got the point, right? And functions are not objects in Java. But in Scala, even functions are objects. So the same thing, Okay, we cannot apply for what? Java. In that way, if we compare Java or C Sharp with Scala, we can say they are less object oriented. I don't say percentage like that. I don't give you the percentage kind of thing, but we can say these are less object oriented, Java and C Sharp. Of course, Python and Scala are pure object oriented. Even in Python, everything is an object oriented. And Scala is also pure object oriented. Even Python is pure. And C++, of course, it has both mixture of both functional and object oriented programming. So it is also less pure object oriented. It is not pure object oriented. It is, we can say it's a bit less comparative to Scala and Python. Got it right? So that is one thing. And second thing, if you want to implement an OOP things like, here we need something like classes and traits in Scala. Using these classes and traits, we implement this object-oriented programming. You understand about this later. You don't need to worry about what is a class or what is a trait. It is not necessary to understand all this in the beginning itself. Just have an idea. We'll talk about it in detail when we go to the object-oriented programming. Is it clear now? So that is one more thing. Is it clear? Next one. So also we have, like, there are many more concepts you are seeing here, right? But the basic thing which is used to implement what is that? Your OOP programming is the basis for either we use classes or traits to implement object-oriented programming. Also, there are something like mixins. Okay, what we call something like mixins here. Uh, these are, when I say mixin means mixin traits actually. What we say mixin traits. With the help of this, what we can do is we can overcome the problem of multiple inheritance. Excuse me. Generally, when you talk about this pure object-oriented programming, we don't implement multiple inheritance using classes due to certain situations. We'll talk about it when we go to the OOP. But with this mixin-based traits, we can overcome that problem still. That is clear, right? And that is also one more advantage of OOP. Anyhow, we get a detailed analysis about all this when we move to the OOP. But this is a simple idea. What is OOP means it should have all these features. And when you say about Scala, Scala is pure object-oriented programming, and we implement OOP concepts by using something like classes and traits. Might be you can ask me a question: what is a class? What is a trait? What is a mixin trait? And we come to know about it when we start discussing about this OOP. Is this clear, folks? Can I get S from all of you? Can I switch to the next topic, next feature now? So you understand this, right? This is about, I told you actually, mixin based composition means nothing but mixing traits. You can go through this paragraph once now. What is that? Object oriented means here everything is an object and it has types and behaviors. Okay, that anyhow we talk about it and we implement that with the classes and traits, and also possible for having this is subclassing is nothing but inheritance. Okay, as I had discussed, and mixin-based composition means implementing, overcoming the multiple inheritance. We talk about it, nothing to worry about it. Next one. The second feature we have to talk about Scala is functional programming. What is this functional programming and why do we need functional programming? Let's talk about it. So second feature here is Scala is a functional. So let me analyze this. When I say functional, so we come to know about all this stuff. What is that? See here, the basic thing to implement programming is functions. Suppose if it is OOP, the core thing is in object-oriented programming, objects plays a very important role. In functional programming, functions are building blocks for writing a code. In OOP, objects are building blocks for writing, are building blocks for a code actually. Okay. So now, when I talk about functional, functions are building blocks. With functions, we implement most of the coding. And the advantage of scalar functions is even in scalar, even functions are objects. What is that? Even functions are objects. That is one thing. And you can do a lot of things with functions in scalar. What is that? You can have nested functions, a function within functions, and you can have function currying. What is that? You can have function currying. What do you mean by currying? Having multiple parameter lists. Okay, you can have higher order functions, higher order. Anyhow, we have a detailed discussion about it. We can have higher order functions. Okay, what do you mean by higher order functions? When you talk about higher order functions, it's nothing but passing. What is that? Passing function as a parameter to another function. That's what we call a higher order function is. Okay, nested functions means functions within functions. Function currying means we can have multiple parameter lists here, which is possible only in Scala. I didn't see this kind of having multiple parameter lists in Java or C Sharp or C or C++. But that is possible only in Scala. You got the point, right? You understood this, and also we can also create some anonymous functions which makes the length of the code very simple, like lambda functions. What we call, we have something like lambda functions, okay, where we can reduce the length of the code by implementing lambda functions. You understand this? In this way, when you talk about functional programming, here functions are the basic building blocks which helps you to implement code in the most simple way. And then we can implement functions in different styles, like with nested functions and with function currying, where we can pass multiple parameter lists, where higher order functions passing, when you talk about higher order passing function as a parameter to another function, lambda functions, where we can simplify the length of the code with lambda functions. And we can also call lambda functions as what is that, anonymous functions. They don't have any name here, but they are very crucial and very important in Scala. You got clarity here, right? So that is one more important thing here about Scala. I think this is clear for all of you folks. Understood? So now after this, what else? Then once we get an idea about this, maybe you can just have a quick walk through the document once here. So you can see here we had discussed all this. Higher order, of course, lightweight is fine, not a big problem. And also one more thing, case classes. With in this functional programming, we come across something called case classes, and which supports pattern matching. So what is this pattern matching means? See, one more advantage of functional programming is having case classes. The purpose of case classes is they supports very well for pattern matching. What matching? Pattern matching. Okay. What do you mean by pattern matching? This helps you to search for your data, to search for strings. When you are doing very big data analytics, data searching is one of the most crucial thing we do in our day-to-day activities. So case classes are very important in functions, actually, in functional programming, because they help to implement pattern matching, and we see that how to implement all that with the practical examples. This is just an analysis, okay? You got an idea here now? And also, one more thing here is singleton objects. What do you mean by singleton objects? See, this is also part of functional programming. See, as we had discussed, everything is an object. So the advantage of singleton object is we can group lot of functions into one object. That's what we call singleton object is. And for a singleton object, we can create only one object. At most, we can provide only one instance. One instance means one object. We cannot have multiple objects here. And we can control number of objects. Singleton itself is one object. We can't have more than one object. And the purpose of singleton object is we can group lot of functions inside this singleton object. So this is one way of what is that is having a more optimized and sophisticated functional coding in Scala. You got the point, right? So this is idea about what is that, guys. This is about Scala functional programming. Suppose if you are writing any programming, we didn't start with classes and traits then. The best way to write programming, to start programming, is with singleton object. I'll show you how to create singleton objects once we finish this introduction part. In the next part, once after we install software and start running the program, the first program itself will start with the singleton objects. Then you understand it very easily how simple it is to implement functional programming in Scala. But remember, whether it is functional or whether it is OOP here, everything is an object. The data types or the functions or the classes or whatever you name here, everything is an object here. Okay, you got the point. That's why in that way we can tell Scala is a pure object oriented programming. Do you understand this? You got clarity here, right? So this is about what is that about the point functional programming here. Of course, there is furthermore few things like more elaborated thing which we can skip for now. We can ignore it. Okay, but this is the very important information as far as the documentation of Scala is concerned, official documentation. I'm not talking about all the website part or something else. Okay. Next, another thing we need to talk here is Scala is statically typed. What do you mean by statically typed? Generally, when you talk about this typed languages, we have two types of languages. So one is, I'm not talking about low level or high level. This high level languages, again, we can split into two types or classify into two types. One is statically typed. What is that? Statically typed. The other one is dynamically typed. What is the difference between that? Statically and dynamically. The difference is simple. When you talk about statically typed, you define the data type at the time of declaration itself. You don't need to wait further actually, and that is statically typed. Once you declare data type for a variable, you don't change it. You cannot change it when you execute at the time of executing or running the program. That is a statically typed language. Whereas when you talk about dynamically typed, you can change your data type at the last moment. If you change your value, automatically the data type changes. That is a dynamically typed changes. But in one way, we can say that in Scala, we can apply both approaches. The beautiness of Scala is you can implement both statically typed as well as dynamically typed styling. But still, even though we can have a dynamic approach, but internally it is a statically typed. As per the official documentation of Scala, Scala is a statically typed. It's nowhere it's mentioned it is dynamically typed. So, but I see because after exploring couple of websites and couple of books, I see people mentioning it as a what is that Scala is dynamically typed also. But as per the official documentation, I didn't find it anywhere. But we can have an approach like that, but implicitly it is statically typed. Okay, I got the point, right? So that's a clear analysis. Still, if you have any doubts, you can please go and refer to the official Scala documentation. Maybe you can just type in Google Scala documentation. You can. Otherwise, I will navigate through all the official resources. Everything to you, nothing to worry about it. So you got point here, right? That is one more important thing we need to understand. So let's just review this content once. It is equipped with the expressive type system that enforces statically that abstractions are used in a safe and coherent manner. I had explained clearly what is statically typed now. In particular, the advantage of having statically typed is it supports this kind of type system supports generic classes, variance annotations, upper and lower type bounds, inner classes and abstract type members as object members, and compound types. All this stuff. Anyhow, I don't need to read this louder because you can just observe that there. Okay, but while discussing these concepts, you understand how statically typed is very useful for us. You don't need to break your head in the very introduction part of Scala. Is it clear to you, right? So that's the point here. Understood or not now? So next one, type inference. What is type inference? When you talk about type inference, where you don't need to declare the data type is automatically assumed by our it declared or data type is declared by the interpreter itself. You don't need to put semicolon. Semicolon is auto implemented by the interpreter itself. And that kind of thing we call it as what is that? We call it as type inference. And the developer need not to care about all this. Okay, you don't need to control that thing there. So type inference means the user is not required to annotate code with redundant data type information. Here type information means data type. Every time you don't need to say data type something, data type something. It is automatically done by the interpreter itself. See how simple and how flexible this is. Huh? And this kind of thing is there in Python and Scala, but we don't have such things in Java or C Sharp or C or C++. There we must declare data type. Type inference is not available. Might be in the latest version of Java it is there, but not in the new versions. You got it right. So that's about type inference, guys. Is it clear to all of you? Know? Then after that, the next thing I would like to discuss is Scala is extensible. What do you mean by extensible? Means it's very simple. You can add new libraries to the Scala. We can extend it. We can improvise it from time to time. So for that, Scala is very flexible enough for developing certain domain-specific applications. So means you can easily add new libraries, so that what happens, it can compete with the changing marketing trends in the industry. Okay, so you got the point right. That is the another important point. So we can keep on adding new libraries to Scala. That is one more beautiness of Scala, so that it won't be outdated. So you got it right. So that is one more thing. Interoperate means, see, when you talk about Scala, one important point is Scala is built on top of JV. And in fact, Scala is built on top of Java. It uses JVM, Java Runtime Machine, Java Virtual Machine, otherwise we can say. So even JVM is used for executing your Java programs. The way Scala program executes internally is almost similar to Java. And also Scala uses certain Java packages directly in Scala itself. So in that way, it interoperates. Interoperates means it will operate along with the Java thing actually. That is the JVM part. So the advantage of it will closely, we can closely work with Java style of coding also with Scala. You got the point, right? So that is what we call interoperate. Means internal operation. So how this happens, it interoperates with the JVM. The advantage of this is it has a close connection with the Java kind of a programming style. Understood? No? So in that way, what happened, as I discussed earlier also, Scala can directly use certain libraries of Java directly. We don't need to again recreate those libraries in Scala. And might be you can ask me a question. As you are using them directly in Scala, should I have any idea about Java knowledge? See, when you start learning basics properly, it is same for Scala or Java. For understanding the fundamentals is very important in the beginning. Once you know that, automatically you understand how to work with the rest of the things. But to be good with Scala, I don't say that you should be really good with Java. It's not necessary to have a Java knowledge, because similar kind of concepts we have in Scala, we discuss them. That is more than sufficient for us. Is it clear to you right now? Even though we can directly use certain libraries of Java in Scala, still what is the point? Still we can make it up to Scala without Java knowledge. Is it clear to all of you now? Any questions, guys, so far? I think we have a good analysis so far. Let's quickly recap what we have discussed in this introduction part. So finally, what is one pointer? First thing, when you talk about Scala, actually, let me summarize this. We'll summarize, okay? What is the summarization here? First thing, why Scala? What is the power of Scala? In fact, if somebody asks you this question, let me explain this. Scala acts as a bridge between functional programming and OOP, or it's a combination of both. Suppose if you talk about C, C is only functional. If you talk about Java, Java is only OOP. If you want to have both a functional style as an OOP and an OOP style of coding in one language, then Scala is most recommended. And Scala is more pure object oriented, and it closely works with the coding style of Java. And the other language, if you ask me, is there any other languages other than Scala which have this kind of similarity? Then I can say Python. Even Python has a mixture of functional as well as what is that? Another one is OOP. So even Python is also that. Is it clear now? But Python doesn't closely work with the Java libraries. Python has its own libraries for everything. Is it clear now? So Scala is a hybrid language. What I can say is that it's a hybrid language which has features of what is that? Which has features of both what is that, gentlemen? Features of OOP as well as what is that, functional. Are you fine with this, sir? Guys, are you able to follow, or am I confusing you? No, I don't think I am confusing. We are very clear with the concepts, right? Next one. When you say OOP, it should have certain concepts like objects, like classes, okay, all that stuff, isn't it, or not? And one more important thing is, if you want to create any OOP programming, you should use either classes or something like traits, okay? It is too early to discuss this, but just keep in mind, okay? We'll talk about them. Then after that, classes are traits. Okay, the next thing we can discuss is what is that, is functional programming. What about functional? When you talk about functional, here the basic building blocks are functions, and we can create different style of functions here. Okay, what is that? We can have nested functions, we can have function currying, okay, function currying. We can have multiple parameters. That's what multiple parameter list, that is a function currying. And then we can have higher order functions, and also we can implement something like case classes with pattern matching. Okay, that is very useful there, very important also in the real-time applications with pattern matching. Okay, so all this sorts of stuff we had discussed. So that is the advantage of what is that, functional programming. Is it clear now? Then after that we came to know what is that, Scala uses what is that, one more important thing is it uses can you just tell me, anybody can tell me? Okay, it interoperates. What do you mean by interoperates? Simple, we can work with Scala on JVM, isn't it or not? So it closely associates with Java and work together. And also we can directly use libraries of Java, certain libraries into the Scala. So it interoperates here. And also one more thing, what else we had discussed? Then of course singleton. One more important thing is it uses a singleton object. The advantage of singleton object is we can group functions. And also what is that? It is statically typed. I had discussed what is that here. In a statically typed language, the data type is declared at the time of what is that, declaration itself, so that we cannot modify it when you at runtime. Such kind of type declaration, data type declaration is called statically typed. So Scala falls under such kind of category language. Okay. So this is, I think this is clear for all of you, right? So in the next class, I'm going to talk about language fundamentals. I hope this is clear for all of you. So I hope this is good for all of you, right? In the next class, we see the software requirements. What are the different IDEs we need to use to implement Scala programming, and also we see how to install them and how to run a simple application in that. Is it clear to all of you folks? Or any questions so far? So what is that? You can type in the chat box if you feel shy to ask me the questions. So what is that? Should I learn Java? No, I don't think you need to have any idea about any programming language. Just concentrate on the programming, just on the sessions enough. We'll do we'll learn Scala from very scratch actually. Okay, from very beginning and fundamentals, language fundamental. We start with language fundamentals. So another question I'm seeing there. What is that? You are saying that Scala is acting as a bridge between acts as a bridge between functional and OOP. So what is the advantage of that? Which one should I use? See, the advantage of having both in one language is depends on requirement. You can choose either functional or either OOP. Okay. Suppose you are working with a big data application. Okay, in big data application, mostly we can use what is that functional coding to implement the Scala programming. We can use a functional singleton object and write all the code in that singleton object and run the code, and it will simplify your coding actually. You got the point, right? Suppose you are doing some web applications, then in such cases we need to implement what is that? We need to implement the what is that OOP kind of style of programming. Got it right? And I'm seeing one more question here. Let me answer this. Could you just explain us where we can use Scala? You are talking about Scala, fine. Yeah, might be if you know, but the very important area where Scala uses one thing is big data applications. That too, it is very much connected with the Spark. Suppose if you talk about Spark framework, okay, without Scala, most of the Spark applications are not implemented. Of course, if you want, you can use Python in Spark or you can use Java in Spark, possible. But the point is, Spark directly comes with Scala. It is implemented with Scala implicitly, the libraries, everything. So it has a very close connection with Spark. So most of the applications in Scala, which in Spark, are developed with Scala. Okay, so that's why if you talk about big data, like when you ask me Hadoop actually, so definitely Scala has a very key importance, a very crucial importance. Okay, and also of course now even Scala is used for web development, like in very frameworks like this gaming frameworks, web application frameworks, and many more other new things actually. Slowly, actually, what happens is Scala also is gaining the prominence in the market. Okay, earlier the purpose of Scala is very limited for working with Spark applications, but now it is emerging as a tough competitor to Python and Java and again C Sharp. All this actually, you see the slowly the dominance of Scala slowly in the market. Okay, so any more questions, guys? I think you are asking me good questions. I like it. Few more, any more questions? So anyhow, no more questions. Thank you very much. Tomorrow again, we meet at the same time. Thanks for attending this session. Thank you very much. Please, okay, register yourself with the team management, okay, so that we can continue with the further sessions. If you have any questions, you can get back to me. Okay, on my mail ID, this is my mail ID, manohar.scala@gmail.com. Okay, is it clear now? Right. And also you can also view this Scala videos on Manohar Space Data Manager, or I had modified it to something like Data Tribe. Please check either one of this. You can find my videos here, and also you can just you know you can ask your queries under that chart query. Right, comment section. You can post the comments for any questions, so I can answer there. Okay, and also you can contact me on this number for if you want any kind of online sessions, or for any of your friends or any corporate training. Okay, is required, but corporate training I'm not sure. We can do online because I'm a working professional here. I work for big data. Okay, but I am also having a good knowledge on Java, Python because I had experience of working with Java and Python also before I moved to big data. So there is a good understanding of all this language languages actually. Okay, okay. So you can contact me on this number. Okay. So thank you very much. Corporate, I'm not sure, but we can make it on weekends or just for limited period because I have to take some break from the office timings. Okay, but otherwise it's fine. Okay, we can make online. Thank you very much. We'll make. I'll give the content of scale also, so that we can discuss have more detailing analysis on this. Okay, we'll meet again tomorrow. Thank you very much.